Hello, so this is for another example, another activity in the book, and what we're going to be doing here is using an LED that will light up with different brightnesses based on that flex sensor that we made. Now you don't have to use a flex sensor that you made, you can just use any flex sensor, but it's much more fun with one that we've made, and then it means we can really configure how that flex sensor will look in our circuit and our wearable. Simple little bit of code here. All we need is to define three integers. They're just straight up here at the top bit of the code. We need to define our LED pin, our flex pin, and a flex value. The LED pin, don't forget, for your board, you'll need to find a PWM pin. That means that it's able to output a different amount of values. So it's not just that binary on off, it will do different values, which is what we want because we want the LED to have different brightnesses. We then have the flex pin, and again, choose a analog in for your board. The 10 works on the circuit playground as an analog input because also we do want different varying values. Then we head into the void setup. Nice simple bit of setup. We're just defining our pins as an output and an input, and we start the serial monitor. As we've seen before, this means that we can then check the values in that serial monitor for the code. If we look now to the void loop, this is where the code gets repeated. We have the flex value, which will take on whatever it reads in the analog values from that flex pin. This value we're then going to print to the serial monitor so we can make sure that it is working how we're expecting it to. Now here, the flex value, we're going to map it. So what that means is this map function, it will map the values that we're taking in, the minimum and maximum, and it'll map it to another set of values. So these first two values are what our flex sensor is putting in, the lowest and the highest. And then let's leave these second two numbers the same because it's for the brightness of the LED. Now these first two numbers, you will probably have to change. I would maybe start with 700 and 900 because that should cover most variables, but it will depend on your flex sensor. For mine, when I've tested it with my multimeter, it roughly was 848 and 1015. Then all we need to do is take that number and do an analog write to that LED pin. Now this means it will give it that value, whatever it is, and it will change the brightness of the LED. Then we have a short delay so we can see the changes. So we'll upload the code, make sure you have the correct board and port selected, and then go to upload. And I will have a look at the output. So it's done uploading, which means it's on our board now. And what we're going to do is I'm just going to come up here and go to the serial monitor. So that will then open down below. And this shows the values of that sensor. So as I move and bend this sensor, these values are going to be changing. And what happens there? Oops, let me get to the bottom of that code. And it's changing as I'm bending them. Okay, so we can see these values changing. And then we can also see the difference in our LED according to what we're doing. Okay, so all we're doing is mapping the values to the LED and we're changing the brightness based on how much we're flexing it. Now I've used very large LED because I'm trying to show you the different effects. You don't have to use this large LED. You can choose a smaller one, or actually one of the sewable LEDs would be great to see on your wearable. If there's, the LED's not working, things aren't going correctly, always just check your connections here. Make sure that one of the outputs that we've sewn in goes straight to the number 10 on your board, and the other one does go to ground with that 10K resistor in place. And then also check that your power is connected and hooked up, and obviously that your board is also plugged in. And then all that should happen is as we bend and flex, this will change the brightness.